Hello all, this is Mr. G, and this is our warm-up for today's lesson. So pause the video right here, give this problem a shot, and come back when you think you have an answer. We're going over in 3, 2, 1, let's hit it. It says graph the equation 2x minus y equals 8. Now as soon as you saw this, you should have thought, oh, I'm going to need y equals mx plus b. This is going to be a linear equation, so we need slope-intercept form, y equals mx plus b. Let me rewrite this over here so I have a little bit more room to work. 2x minus y equals 8. Because we're going to need to do a little work before we can start graphing it. We've got to get y by itself. This is something we should be good at from Algebra 1. I'm going to subtract 2x from both sides of the equal sign to cancel that out. That gives us negative y equals negative 2x plus 8. Then, to get y by itself, we have to divide by negative 1, which means we divide every term we see by a negative 1, and we get y equals 2x minus 8. 2x minus 8. And did I do that one correct? Yep, just checking my work. Looks good. Now we're ready to graph. So first I'm going to find my y-intercept, which is negative 8. So I go down to negative 8 on the y-axis. Then we use our slope, which is 2. I'm going to put 2 over 1 so it's easier to see the rise over run. Then I just go up 2 over 1, and I'm going to do that over and over and over again. So up 2 over 1, up 2 over 1, up 2 over 1, all the way till I run out of space. Gotta scroll back up 2 over 1, up 2 over 1, up 2 over 1. And there's our line. Faces in the way. There we go. Now, if we wanted to get points on the left side, we didn't really need to because we started so low. But if we wanted more points over here, we would just reverse it. Instead of going up 2 and right 1, we would go down 2 and left 1. Yeah, hopefully that made sense. Hopefully that's the answer you got. Now, we're going to need this skill during today's lesson. Keep in mind, ladies and gentlemen, I'm not going to be showing every single step for this. This is something we should be good at. We should be able to find a y-intercept and a slope and then graph them. So, if that's something you need to review, do some extra practice on your own or ask me for help. Now, we're not going to jump to our objective just yet because, spoiler alert, there's not going to be a lot of new Algebra 2 material in today's lesson. Today's lesson is really just a review of some stuff we should know from Algebra 1. So since there's not a lot of new material to cover in this video, I thought we could go over the homework that was assigned last night just so everyone can check their answer, and if they got it wrong, see how to do it correctly. So the first part of the homework was to do example 5 from yesterday on the board, which was x plus y equals x over 3 minus 2, and 6x minus 9y equals 36. And the answer I got was 1.5 and negative 3. Now, whether you use substitution or elimination, I'm going to go over the method I used to solve it. Whether you use one strategy or the other, the first thing I would try and get rid of is that division by 3. So let's color code these. I'll do the first one in blue. Second one, if we have to make changes, we'll do that in green. But the first thing, let's multiply this first one by 3, because that will cancel out the dividing by 3. We just distribute to everything we see. So x becomes 3x, y becomes plus 3y, equals x over 3 times 3 is just x. Remember that's what we're doing. To cancel out the divided by 3, we multiply by 3. And then negative 2 turns into negative 6 when we distribute the 3. I'm not done with this one just yet. Let's combine those like terms. I don't like having a 3x and an x here. Let's get them together. So let's subtract x from both sides, and that will give us 2x plus 3y equals, the x's cancel out, just negative 6. This looks a lot better. Now let's recopy our green equation because I don't think we need to make any changes yet. It's 6x minus 9y equals 36. Now, ladies and gentlemen, this to me is just dying to be solved by elimination. And we don't see opposite coefficients yet. I mean, the x's and y's are all lined up vertically. That's good. But there's nothing that's going to cancel just yet. I see a 2 and a 6 for the x's and a 3 and a negative 9 for the y's. So the question is, which one do we want to line up? I'll match up the x's. And to do that, we're going to multiply the top one by a negative 3. We'll do it. Because we already have a positive 6 down here. We want the opposite of that. We want a negative 6. So let's distribute. Tell you what, let me just copy it down here because that'll make this the least amount of copying possible. So negative 3 times 2x is negative 6x. Negative 3y times negative 3y is negative 9y. I'm trying to think and talk at the same time. It's not working. And then negative 6 times negative 3 is positive 18. And now we're ready to combine because now the x's will cancel out. So the 6x and negative 6 go away. That becomes 0. The negative 9y's become negative 18y. equals 36 and 18. That's 48, 54, if I'm doing that correctly in my head. Hopefully I am. And then we divide both sides by negative 18. And that's going to be a negative, let's see, that's going to go in 3 times. Is that correct? I'm going to double check myself. Grab a calculator here. 54 divided by 18. Yeah, that's negative 3. So y equals negative 3. And then all you have to do is plug it back into any equation to find our x value. What's the simplest equation? Probably this one right here. Let me undo that. So let me draw a line here. So now I'm going to put 2 times, oh, y was negative 3. So it's still 2x plus 3 times negative 3 equals negative 6. Sort of running out of space there. And then we just solve. So it's 2x minus 9 equals negative 6. Add 9 to both sides. Scroll down a little bit. We get 2x equals 3. And then divide by 2, and that's 1.5. Hopefully that's what I have for x. Otherwise I did something wrong. 1.5. Very good. Very good. All right, so that was example 5 from last night's homework. Now, let's go over number 62, which was a word problem. It says, in the final round of a singing competition, the audience voted for one of the 2 finalists, Luke or Sean. Luke received 25% more votes than Sean received. Altogether, the 2 finalists received 5,175 votes. How many votes did Luke receive? So we're looking for how many votes Luke got. Oh, my face is over the answer. The answer I got, in case anyone just wants to check it, is 2,875. But let's go through how I got that. There's 2 big pieces of information here. They say that the 2 finalists received that many votes, and they also said that Luke received, let me do these in different colors, Luke received 25% more votes than Sean received. Now that's critical. Let's start with the 2 finalists receiving 5,175 votes, because it's kind of easy to create an equation based off of that. So the equation would be, let's see, it's Luke, I'll use an L for Luke, plus Sean. The number of votes they each got needs to add up to 5,175. That's essentially what they're saying. So what I've got underlined and now outlined in blue, and what's right here, essentially mean the same thing. One is just sort of in math language. Now we need to move to the green, the fact that Luke received 25% more votes than Sean received. Now, some students, how do I want to say this? The equation for this one is not as obvious to everyone. That's, I think, the best way to say it. Here's the way it makes sense to me. So what if they got exactly the same amount of votes? What if they got exactly the same amount of votes? Well, that would just be, okay, L equals S. The number of votes Luke got would equal the number of votes Sean got. Well, okay, in this equation, L equals S, what number is in front of the L and the S? Well, hopefully you remember, there's an invisible 1 in front of each. So it's 1 times S and 1 times L equals 1 times S. But we've got a percent here. So here's my question to you. What does this 1 or that 1, it doesn't matter, what does a 1 mean if we wrote it as a percent? Well, 1 is 100%. Because remember, with a percent, we always move the decimal over twice. So 1, we move it over twice. We pick 2 more zeros. That's 100%. So if Luke received 25% more votes than Sean, that means that Sean, for these 2 things to be equal, Sean needs to be multiplied by something more than just 1. Because we need to multiply Sean by more than just 1, because he's got the lesser number of votes. We need to make his number of votes bigger if they were going to equal Luke's. This is where the 25% comes in. So Luke received 25% more votes. That means Sean would need 25% more votes if he was going to catch up to Luke. So he can't just have 100% of the votes he got. He would need 125%, 1.25. So this is the equation. Let me write this now just in green. So it would just be L equals 1.25 times S. That's how we would create an equation using that fact. Now, this isn't the only way to do it, but this is the way that makes sense to me. If you did it a different way and got the correct answer, that's a good thing. But from here, we have a system. We have 2 variables and 2 equations, so we can solve. I'm going to use substitution here because we've got L equals in the second equation. So I'm going to rewrite the first equation, but wherever I see an L, I'm going to substitute in. So instead of L plus S, it's 1.25 times S plus S equals 5,175. Then we just solve. We combine like terms. We know there's a 1 in front of there, so this becomes 2.25 times S equals 5,175. And then we divide 2.25 from both sides, blah, blah, blah. I'm just showing all my work here. And we get the number of votes Sean got is 5,175. Divided by 2.25, I got 2,300. 2,300. But they were asking for Luke, correct? Yeah, they wanted Luke. So then you just subtract that from the total 5,175. So 5,175 minus 2,300. And you do get 2,875. Hopefully that made sense. So that was a long sort of prelude to the objective. But now we're finally ready for our objective now that we're done going over the homework. So today we're doing chapter 3, section 3. And after today, we should be able to graph the solution of systems of inequalities. Graph the solution of systems of inequalities. Don't need the calculator anymore, so we'll put that down. So now we're talking about not systems of equations, but systems of inequalities. And I can understand a student saying, well, okay, I get that, but why all of a sudden do we have to graph it? I mean, we didn't have to graph anything yesterday to find answers. Why do we have to graph now to find the solutions? And it comes to this question. Why do we need to graph an inequality? Well, let's take a look. We've got x is greater than 7. This is about the simplest inequality you could have. My question to you is, how many solutions are there to x is greater than 7? Well, the answer is there's infinitely many. There's infinitely many. We cannot sit here and list all of the solutions because we'd be here forever. There are infinitely many numbers that are bigger than 7. That's why we need to graph when we have an inequality, because there's not enough time in the world to list all the answers because there's an infinite number of solutions. So basically, just a quick review, we're going to end up with something that looks like this. Two lines, might be solid, might be dotted, and we're going to have shading. Now, my question is, where are the solutions? Hopefully you remember this from Algebra 1, but the solutions are anywhere in the area that is shaded twice. So anywhere where the shading overlaps. So here the shaded region. So like that would be a solution. Or like this would be a solution. This is what I mean when I say there's infinitely many solutions, because I could stay here all day just sort of making points that are solutions. And remember, even though the graph stops right there, that's just because we ran out of space. The graph keeps on going. So we could keep on listing solutions. I could spend the rest of my life here doing this, and I'd still not list them all because there's infinitely many. Here's a question for you. Is that a solution? The answer is yes, because it's part of the shaded region and it's on a solid line. Solid lines means that the line is part of the solution. So how about up here? Would that be a solution? No, that's not a solution. Even though it's on a solid line, it's not part of the shaded region. How about this point right here? It's part of the shaded region, or it's right next to it, but it's not a solution because it's on a dotted line. So the fact that it's on a dotted line means that even though it looks like it might be part of the shaded region, it's not actually the shaded region. A dotted line is just sort of a bound, a limit, a constraint on where the shaded region, the solution set is. Now let's take a look at example 1. It says solve the system of inequalities by graphing, and we got y minus 1/2 x is greater than or equal to -5, and x is less than -3. Let's color code this just so we can sort of keep these separate and know which one we're talking about. Now I'm going to be running through these graphing steps kind of quickly because getting y by itself, finding m, finding b, going right to the graph, these are things we're hopefully already good at. So let's jump right in. Let's rewrite this down here. The blue one has a little bit of work left to do. So first, let's just get y by itself. We just have to add 1/2 x to both sides. That's not too bad. We scroll down a little bit. Then we get y is greater than or equal to 1/2 x minus 5. Now we just find our b and m value. Our b value is -5, so I go to -5, put a point right there. And the slope is 1/2, so rise over run. I go up 1, right 2, as many times as I can. Up 1, right 2, up 1, right 2, all the way to the end. And then in the opposite direction, we switch it and go down 1, left 2, down 1, left 2, as many times as I can. There we go. Now here's where things get a little bit different since this is an inequality. It's not a linear equation, it's a linear inequality. The first thing we have to figure out, is this going to be a solid line or a dotted line? The way we tell is we look at our symbol. If it is just greater than or less than, then it's dotted. If it's greater than or equal to or less than or equal to, then it's a solid. So since this is an or equal to, it's going to be a solid line. And that's not too hard to remember because basically, if you're looking at your inequality, if there's a solid line under it, then you make your line a solid line. All right, now the next thing we have to worry about, since this is an inequality, is the shading. Do we shade above or below? That's always the way I think of this. Okay, we can shade above or we can shade below. Now, how do I want to say this? The key is looking at y. If y is greater than, if y is bigger, we shade above. If y is less than, if y is smaller, we shade below. Obviously, here we see y is greater than, so we're going to shade above our line. I'm just going to shade in a little bit right now because I'm only going to really want to shade in the final solution set where the shading is overlapping. But the blue part is all done. Now let's take a look at the green, which was just x is less than -3. Now, fortunately, the variable here is already all by itself. So there's no, we don't have to solve or do any more work like that. And we only see one variable. It's only an x, which means it's going to be either a vertical or horizontal line. So to figure this out, I'm going to go to -3 on the x axis. And again, it's the x-axis because the one variable is x. And then if you remember, we talked about this in a previous video. Whenever it's a vertical or horizontal line, we cut across the axis we're on. Since we're on the x-axis, we cut across it vertically. That's the only way to cut the x-axis vertically. And let me think. It's going to be just less than, not or equal to, so it's a dotted line. Put a dotted line there, going vertical. Now we have to worry about the shading. And I know earlier I said we always worry about above or below. This is the one exception. This is the one time, since it's a vertical line, where we can't really talk about above or below. It doesn't make sense. This is the one and only time when it's a vertical line when we have to worry about shading left or right. Any other time, with any other line, we worry about shading above or below. But since this one is vertical, we have to worry about left or right. Let me see. So it says x is less than. Since x is smaller, we shade to the left. So to the left of that green dotted line. So that means the final solution set would be this big area right here. I'm not going to shade in everything like it's a coloring book, but hopefully you get the idea. And remember, it doesn't just stop there. It keeps on going. It keeps on going. Oh, I forgot my arrows on the green line. I guess that's not that big a deal, but whatever. It's important to have it. So any point in this red area, that red section where the shadings overlap, would be a solution to these two problems. Oh, to this system, which I guess is two inequalities. Whatever. Let's take a look at example 2. I want you to pause the video. Try this one on your own. So we're going to go over the answer in 3, 2, 1. Let's go. We'll do the first one in blue. There's actually no work to do with that first one. It's just y is less than or equal to 5. So, oh, wait, no. There is work to do there because y is not by itself. That was almost a bad mistake by me. So let me rewrite that down here. Negative y is less than or equal to 5. We've got to get the variable by itself. So to do that, I'm going to divide by -1. And then we're going to get y, because the negatives cancel out, is less than or equal to -5, right? No. I made a mistake here. And this time I actually meant to do it. A lot of students forget to do this, but we need to change this inequality symbol. Anytime we divide or multiply both sides of the equation by a negative, we have to change the direction of the inequality sign. I'm going to say that again, it's so important. Anytime we multiply or divide both sides of an inequality by a negative number, -1, -7, whatever it is, you have to change it from a less than to a greater than, or vice versa. Essentially, you change the direction of the inequality symbol. So it's very easy to forget that. Hopefully that sounds familiar though. So now I'm going to go to -5 on the y-axis, cut across this axis, and get a solid horizontal line. Remember, it's solid because we see an or equal to under that inequality symbol. Shading, y is greater than, so we're going to shade above. Shade above. Okay. Now let's take a look at the green. And again, there's a little work to do here. Let me copy down here. 3y less than x minus 12. Scroll down. Let's get y by itself. divide everything by 3. Remember, anytime we divide both sides of an equation, we do it to every term we see. So a lot of students had trouble with this, or sometimes have trouble with this. Remember, there's a 1 in front of this x. Let me do that in a different color. I feel like that's too crowded. There's a 1 in front of this x, which means that the slope is just 1/3. It's 1/3 x minus 4. Now we're going to go straight from this slope-intercept form to our graph. So let's see, the y-intercept is -4, so it's right there. And then the slope is 1/3. So it's up 1 over 1, 2, 3, up 1, 1, 2, 3 to the right, up 1, 3 to the right. Oops, let's get that out of there. 1, 3 to the right. Now going to the opposite direction, we flip. So we go down 1, 3 left, 1, 3 left, 1, 3 left. And solid or dotted, it's going to be dotted since there's no or equal to under our inequality symbol. Oh, shading, I forgot the shading. It's y is less than, so since y is smaller, we shade below. And that will give us our solution set. There will be double shading in this section right there. So any ordered pair in that shaded region will be a possible solution. And I don't know why I said possible. It is a solution to this system. All right, hopefully that's the answer you got. If not, just go back, check your work. Hopefully it makes sense now at least. Our homework assignment for today is page 153, numbers 11 through 13. Just those 3 problems. Now, like always, if you're a student who right now is thinking, oh man, I didn't remember this from Algebra 1 as much as I wish I did, just do some extra practice. There's more problems on this page besides the one I'm assigning, besides the ones I'm going to check tomorrow in class. So, just practice them. Check your answers in the back of the book. See if you're doing them correctly. The more you practice, the better your skills will get, as long as you're checking your answers and practicing correctly. All right, that is the end of the lesson. Hopefully that all makes sense. As always, if you have questions, please reach out to me. But other than that, enjoy the rest of your day.